So what we're going to start with is a quick review of statistics. So this is going to be content that you have hopefully studied in year 11 and potentially even year 10. Kind of simple concepts such as expected value, variance, and standard deviation. What exactly is a random variable? You know, we're studying discrete and continuous random variables in year 12, both random variables. What is a random variable? And then we're going to look at the difference between discrete and continuous random variables. This is a really important point to understand because obviously when you get an exam, say in your second internal exam if you haven't had it already, and your external exam, sometimes a question doesn't tell you whether the distribution you're being asked about is discrete or continuous, right? Sometimes it doesn't tell you, so you really need to be able to distinguish between the two. The other reason that this last up point is very important is because in some questions you're actually going to have to use both, right? The most common example of this is if you are given a few values that are continuous random variables, and you need to use this continuous distribution to find a p-value for a discrete random distribution. So, I can't quite recall if we're going to look at one of those questions today, but probably not because they are generally pretty complex. You might only have a few of them in your textbook, but they do come up. So if you would like to have a look at those, I'd recommend finding a few of those in your textbook. Alright, so let's get into what expected value is. So, the expected value is what we usually call the mean of the distribution, or mu, which is a Greek letter, this kind of like long U kind of looking thing. So it is kind of the value, I mean it is what it is, it's the value that you would kind of expect to get if you were taking a trial, right? So we can find the expected value by summing the products of each value of x and its probability. So this is the formula that we have right here. Of course, this symbol, sigma, it's an uppercase sigma, represents sum of. So what we're looking at here is the sum of x multiplied by the probability of that x value occurring, right? The formula looks a little bit complicated if you're unfamiliar with it, but once you go through an example, it really is quite simple if you're getting confused by the notation, because I know that I sometimes do as well. So, we're also able to find an expected value of a function of x. So, if we have the expected value of g of x instead of just x, like we had in our last slide, then what we can do is multiply the value of the function of x by the probability of x occurring. And we're going to go through an example of that right here. So, say our function of x, g of x, is 3x plus 1. What we're going to be doing is we're going to be multiplying 3x plus 1, g of x, by f of x to get our mean, right? Or our expected value. And then, of course, this is just our formula from the last slide, and this is just the expected value of regular x. Alright, now getting on to variance. So remember, variance is a measure of spread. So it tells us kind of how spread out the data is, right? Whether it is really closely concentrated in one spot, I'll draw a quick but terrible diagram for you guys. If it's really concentrated around one spot, it might look something like this, right? Where it's all concentrated in this one spot here, but if it is really spread out, it might look something like this, right? Again, that's a terrible diagram, not an art student. But as you can see, if it's all really close together, really compact, we're going to have a low variance because each value doesn't vary much from one another. But if it's really spread out, like if it's kind of lower and more spread out, then we're going to have a high variance because each value varies a lot more from the other ones. Right, so let's get into how we actually calculate variance. So variance is represented by var of x. We don't have a special symbol for it. And it's calculated by finding the expected value of x minus mu. Remember, mu is the mean or the expected value, squared. So this is kind of an application of our formula, this one here, where we have the expected value of a function. So our function here, g of x, is x minus mu squared. So mu is our expected value. It's going to be the number that we find using our expected value formula from here. Oh, right. So kind of expanding this out a little bit, what we're going to have is x minus mu squared multiplied by the probability of x and the sum of that. So this is how we find our variance. Now let's get on to the last measure that we're looking at, and this is standard deviation. So hopefully you've heard of standard deviation before. Remember, standard deviation is again a measure of spread. It tells us about how spread out the data is. And we can calculate the standard deviation by finding the square root of the variance. Now, really quickly before we move on to the other stuff that we have done here, I just want to make one thing clear. You are not given the standard deviation formula, this one here, on your QCEE formula sheet. So you're given your expected value formula, you're given the variance formula, but you're not given the standard deviation one. So if I were you, I would think of a way to remember this. Obviously, it's not that difficult in concept. The tricky thing is, at least for me, and I still can't remember this without thinking of my kind of the way that I remember it. I can't just remember it off the top of my head. And that is that the standard deviation is a square root of the variance, not that the variance is a square root of the standard deviation. Like I would always get confused about where the square root goes. And it's really easy to make that mistake, especially in an exam where you're just kind of like, worried about not finishing the exam on time. You want to get everything done quickly. You're just kind of writing down what you remember. So what I'd recommend is thinking of a way to remember it. So there's kind of two ways. Obviously, you can have whatever way you want, but the two ways that I remembered it was that if we have standard deviation, I'd kind of think of the S and the D and think squared. So I'd think standard deviation squared equals variance if we just took this over. That's one way that I remembered it. The other way is on your formula sheet, you're given the formula for, I believe it's for confidence intervals, finding the standard deviation for confidence intervals. I'd have to have a look again. But you're given the standard deviation formula there, and they have a square root over that. So that is another way that you could remember it. But yeah, make sure you think of a way. Alright, moving on. So, standard deviation is denoted by this letter here, which is a lowercase sigma. This little kind of round thing with the tail. And therefore, variance is equal to sigma squared. So we just took that surd over the other side. What you can see here is a normal distribution, if you haven't done those already in class. So this is a continuous random variable. but the important thing that we're looking at here is actually the standard deviation. So as you can see, we have our mean in the middle. This is our expected value. On either side of the mean, we have one standard deviation, plus one standard deviation, minus one standard deviation, right? And as you can see, the furthest standard deviations we move away from the mean. So here we have 2 standard deviations for the blue and 3 standard deviations for the purple, right? The further we move away from the mean, the more standard deviations we have. So this is kind of an important diagram that you're going to want to remember when we're getting onto the normal distribution and we're going over standard deviations and Z scores and the standard normal curve and all that kind of stuff. But it's just an important thing to actually understand what the standard deviation means. All right. Now let's get on to our next question in our review of statistics, and that is, what is a random variable? So remember, in year 12 we're studying random variables only. We're doing discrete and continuous random variables, so all of the statistics we're doing is covered by random variables. So a random variable is a variable whose value is unknown, or a function that assigns values to each of an experiment's outcomes. So what this essentially means is that our outcomes are a random occurrence, right? An example of this would be rolling a dice 3 times and finding the result. That's random, right? But an algebraic variable, such as graphing a function, is not random, because it isn't kind of dependent on chance, right? It's kind of already plotted out for us. When we're rolling a dice or picking marbles out of a bag or any of that kind of stuff, we might be able to kind of predict what's likely to happen, but we don't know what is going to happen, if that makes sense, right? So we might be able to roll a million dice and kind of say, well, chances are we're going to get half heads and half tails, but the key point there is that we have chances are, right? If it was a non-random variable, we would be able to say, this is what our outcome is going to be, right? So our random variables are classified as discrete or continuous. So quickly pause the recording, have a think. Do you remember what the difference between discrete and continuous random variables are? Right? So discrete random variables are just essentially variables where the outcomes are discrete, right? So it just means that we can only have certain outcomes, and usually these outcomes are kind of like integers, right? An integer just is like whole numbers, right? So just going up in values of 1. So an example of this is getting 1 through 6 on a dice, right? These are discrete outcomes because you can't get 1.5 on a dice. You can't get anywhere between these values. You can only get these values. In other words, there are a set number of outcomes, right? So, here there's 6 outcomes, right? If you're picking marbles out of a bag, there might be a certain number of outcomes, so forth. However, when we're getting onto continuous random variables, these are obviously continuous. So any value in a certain domain is possible. So we could have, not just 1 through 6, but we might be able to have 1573 point, so forth. we could have kind of any value. So continuous random variables typically are measurements, because these are kind of the things that usually can be continuous. So such as height, distance, time. You might get, say, velocity, weight, any of these kinds of things, right? So now let's get on to kind of the bulk of our discrete random variable content for today. So what we're going through today for our discrete random variables is we're going to be going through Bernoulli sequences and binomial distributions. So this is the content that is really specified in your syllabus. So we're going to be going through